Assalamu alaikum student. Hope you ate well. Welcome to new class. Welcome to new video. Let's start our today's class with the name of Allah, which is most beneficent and the most merciful. Today's we learn tag question of class 9th chapter 1st, Fundamental of Chemistry, 1.3 Test yourself. Q number 1. How many AMU 1 gram of a substance has? Answer. The atomic mass unit, AMU, is a unit of mass commonly used in chemistry to express the relative masses of atoms and molecules. It is defined as 1/12 of the mass of a carbon-12 atom. To determine how many AMU are in 1 gram of a substance, you would need to convert the mass from grams to AMU using the molar mass. Q number 2. Is atomic mass unit an SI unit of atomic mass? Answer. The atomic mass unit, AMU, also known as the Unified Atomic Mass Unit, U, is not considered an SI, International System of Units, unit. The SI unit for mass is the kilogram. The atomic mass unit is a unit of mass used primarily in the field of chemistry and atomic physics to express the relative masses of atoms and molecules. It is defined as 1/12 of the mass of a carbon-12 atom. The value of the atomic mass unit is approximately 1.66054 times 10 to the 27 kilograms. While the atomic mass unit is not part of the SI system, it is still widely used in scientific research and literature, especially when dealing with atomic and molecular masses, as it provides a convenient scale for expressing these masses without the need for large numerical values. Q number 3. What is the relationship between atomic number and atomic mass? Answer. Relationship between atomic number and atomic mass. The atomic mass is not directly related to the atomic number. However, there is a general pattern that can be observed in the periodic table. As you move from left to right across a period, horizontal row, of the periodic table, the atomic number, Z, increases by 1 with each successive element. Additionally, as you move down a group, vertical column, of the periodic table, the atomic number increases, but the atomic mass also tends to increase due to the addition of more protons and neutrons in the larger atoms of the lower rows. Q number 4. Define relative atomic mass. Answer. Relative atomic mass, also known as atomic weight or atomic mass, is a dimensionless quantity that represents the average mass of the atoms of a chemical element relative to the mass of a carbon-12 atom. It is expressed in atomic mass units, AMU, or unified atomic mass units, U. The relative atomic mass of an element is calculated by taking into account the masses of all naturally occurring isotopes of that element and their respective abundances. Isotopes are variants of an element that have the same number of protons but different numbers of neutrons. Since the abundance of each isotope may vary in nature, the relative atomic mass considers these variations to give a weighted average of the isotopic masses. Q number 5. Why is the atomic mass of an atom defined as relative atomic mass? Answer. The atomic mass of an atom is defined as relative atomic mass because it is a comparison of the mass of one atom of an element with the mass of a specific isotope of carbon, carbon-12, which is assigned a value of exactly 12 atomic mass units, AMU. This unit is also known as the Unified Atomic Mass Unit, U. The reason for using relative atomic mass is practical and historical. Before the concept of isotopes was well understood, scientists believed that all atoms of a particular element had the same mass. However, it was later discovered that some elements exist in nature as different isotopes, which have different numbers of neutrons but the same number of protons. These isotopes have slightly different masses. Move toward next topic, which is how to write chemical formula. Identify the elements. Determine which elements are present in the compound. Each element is represented by its chemical symbol, typically consisting of 1 or 2 letters. For example, hydrogen is represented by H, oxygen by O, carbon by C, etc. Determine the number of atoms. Determine the number of atoms of each element present in the compound. This information can be provided in the form of subscripts, small numbers, placed to the right of the chemical symbol. Use parentheses when needed. If the compound contains multiple polyatomic ions or groups, you can use parentheses to group them together. The subscript outside the parentheses applies to all the atoms within the group. For example, in the formula for calcium sulfate, CaSO4, the 4 applies to both the sulfur, S, and oxygen, O, atoms. Balance charges for ionic compounds. In ionic compounds, the total positive charge of the cations must equal the total negative charge of the anions. The charges are indicated as superscripts, positive for cations, negative for anions, on the chemical symbols. The magnitude of the charges must be balanced to achieve a neutral compound. Examples. 1. Water, H2O, 2 hydrogen atoms and 1 oxygen atom. 2. Carbon dioxide, CO2, 1 carbon atom and 2 oxygen atoms. 3. Sodium chloride, table salt, sodium chloride, 1 sodium atom and 1 chlorine atom. For ionic compounds. 1. Sodium hydroxide, NaOH, 1 sodium ion, Na+, and 1 hydroxide ion, O. 2. Calcium sulfate, CaSO4, 1 calcium ion, Ca2+, and 1 sulfate ion, So4 to the power of 2. It's essential to be familiar with the periodic table and the charges of common ions to write chemical formulas accurately. Also, practice and exposure to various compounds will help you become proficient in writing chemical formulas. Okay, next we move toward our next topic, which is empirical formula. Sure. Here's a note on empirical formulas. The empirical formula. The empirical formula is a representation of a chemical compound that shows the simplest whole number ratio of the atoms of each element present in the compound. It is also known as the simplest formula. Unlike the molecular formula, which provides the exact number of atoms of each element in a molecule, the empirical formula gives us the relative proportions of the elements in the compound. Obtaining the empirical formula. To determine the empirical formula of a compound, one must know the mass or percentage composition of the elements present in the compound. The steps to obtain the empirical formula are as follows. 1. Determine the mass or percentage composition. This involves analyzing a sample of the compound to find the mass or percentage of each element, usually represented as a percentage by mass. 2. Convert mass to moles. Convert the mass of each element to moles using their respective molar masses. If given percentages, assume you have a 100-gram sample to simplify the calculation. 3. Find the simplest whole number ratio. Divide the number of moles of each element by the smallest number of moles calculated. If the result is very close to a whole number, within a small margin of error due to experimental uncertainties, round it to the nearest whole number. These whole numbers represent the subscripts in the empirical formula. 4. Write the empirical formula. Using the whole number ratios obtained in step 3, write the empirical formula for the compound. It shows the relative numbers of atoms of each element present in the compound. Example. Let's take the example of hydrogen peroxide, H2O2. Suppose we have determined the percentage composition to be 5.88% hydrogen and 94.12% oxygen by mass. 1. Assume a 100-gram sample. Hydrogen, 5.88 grams. Oxygen, 94.12 grams. 2. Convert mass to moles. Hydrogen moles, H, 5.88 grams, 1.008 grams per mole approximately equals 5.83 moles. Oxygen moles, O, 94.12 grams, 16.00 grams per mole approximately equals 5.88 moles. 3. Find the simplest whole number ratio. Hydrogen, H, 5.83 moles, 5.83 moles approximately equals 1. Oxygen, O, 5.88 moles, 5.83 moles approximately equals 1. 4. Write the empirical formula, H1O1, which simplifies to H2O. Thus, the empirical formula for hydrogen peroxide is H2O. Importance. The empirical formula is crucial in chemistry because it provides valuable information about the relative composition of a compound. It is especially useful when the molecular formula of a compound is unknown or difficult to determine experimentally. The empirical formula helps chemists understand the basic stoichiometry and molar ratios of elements in a compound, providing a foundation for further analysis and research. And the next topic is molecular formula. Sure. A molecular formula is a representation of a chemical compound that shows the types and numbers of atoms present in a molecule. It provides information about the composition of the molecule without showing the arrangement of the atoms. To write a note of a molecular formula, let's take an example of a simple molecule, water. Molecular formula, H2O. In this case, H represents hydrogen atoms, and O represents oxygen atoms. The subscript numbers, 2 in this case, indicate the number of atoms for each element in the molecule. So, the molecular formula H2O means there are 2 hydrogen atoms and 1 oxygen atom in the water molecule. It's important to note that molecular formulas do not provide information about the molecular structure or the way atoms are bonded together. For that, you would need a structural formula or other representations of the molecule. The molecular formula simply tells you the relative numbers of each type of atom in the compound. Okay, our lecture is done. If you like this video, please share and subscribe. If you have any question, then write in comment section. Inshallah, we learn more in next class. Till then, Allah Hafiz, fi iman Allah. Thanks for watching.